Good morning, everyone. Can everybody hear me okay? Yeah, I'm sorry about the voice. I'm glad I've got somewhat of a voice today because yesterday that was different. So if you can't hear me, just please tell me. But I'll try to make it through. Okay, so my name is Katrien Hermans. I'm the Business Development Manager for Williams Advanced Engineering. I'll tell you a little bit about what Williams Advanced Engineering does because a lot of people are aware of Williams F1, but Williams Advanced Engineering is not necessarily that well known, mostly because we haven't really been around for very long. We've only been around for a couple of years. I did what Ed this morning said a lot of people do, have tons of slides and then go through it all very slowly. I have tons of slides, but lots of them I'm just gonna flick through because I have nice images, but I'm not gonna dwell on them. Okay, so in order to get the introduction of Williams Advanced Engineering started, we have a little company video, which I think is probably better than hearing through me speaking for 2 minutes. So I'm going to try and set that up. Okay, and I think that captured pretty much the essence of it.
The first win, which was a silver stamp win at the place, was a very fun anyway, and it was the first World Championship.
Up to the checker flag and past it goes Alan Jones. And there is the world champion of 1982, Hickey Rosberg. This is the last corner, crosses the line, and Benson is the winner. Now he's going for it. Exits the chicane, and wins the Japanese Grand Prix. And I've got to stop because I've got a lovely life first.
At Williams, we are so incredibly proud of our history. Since we started the company in 1977, we've won 16 World Championships. We've had some of the greatest names in sport drive our race cars. But we never dwell on our past races, whether we've won or lost. It's always about the next race and striving to do better. At the start of 2014, the team partnered with another truly iconic name in motorsport, Martini, to bring together Williams Martini Racing. What we hope is the start of a very positive future for the team.
Williams has always been moving fast, as Williams Martini Racing, in partnership with Mercedes-Benz, were at the very forefront of Formula One. Since 1977, Williams has been pushing the boundaries of engineering and technology. Williams' know-how is now being put to great use in Williams Advanced Engineering, a new division that we began in 2011, harnessing everything we've learned in Formula One and bringing it to the wider marketplace.
Williams Advanced Engineering is all about energy efficient performance. Of note, we worked on Jaguar CX-75, the supercar that had the performance requirements of the speed of the Bugatti Veyron, fuel efficiency of the Toyota Prius, and the electric range of the Chevrolet Volt. We've worked exclusively with Formula E, developing the battery system and supplying the battery system, and we have strategic partnership with Gizmo, developing a number of high performance products for them, including the time attack and SMG car.
Engineering and technology is at the heart of everything we do here at Williams. Through aerodynamics, vehicle dynamics and electrification, we're bringing energy-efficient solutions to the wider society, and we believe Williams Advanced Engineering is ideally placed to help companies solve some of the biggest problems they face today.
Williams Formula One started as the enthusiasm and the passion for motorsport, motor cars, speed. It's no one man has done this, but it is done with some very clever, resourceful people. This channel is exciting. I just love it. It's not exactly the thing to do.
Okay, well, I think Mike O'Driscoll summed it up quite nicely there. What Williams Advanced Engineering is trying to do is really to take that Formula One expertise and take it and collaborate with companies, with our partners to really tackle some challenges of the 21st century. So the title of my talk is From Formula One to Commercialization. So how do we go through that process of getting from F1 through to commercialization? Okay, as I said, it's quite new to us. We started off as quite a bit of a consultancy business, and the majority of what we do now is still based on consultancy, but I'll show you how we're trying to change that as we go along. A little bit more about the company. I'm not going to dwell too much on that, but we've been, as Williams F1, we've been around since 1977, but Williams Advanced Engineering has only been around for 4 years, so relatively new. And we are the innovation engineering and services company, engineering services part of the business. As you can see in the video just now, we have a brand new facility at the same grounds as Williams Martini Racing. And this is where we have dedicated a special space which has grown exponentially over the past couple of years. And that's, I think, a nice indication of how well we're doing and how what the confidence is in the company in advanced engineering. Okay, we're playing in a couple of sectors. Of course, the bulk of what we do is still around automotive and motorsports, because that's, you know, that's our heritage, that's what we've been doing, that's what we know how to do well. But what we're trying to do is be a little more adventurous as well, look into different sectors, and we've successfully done that recently as well. So civil aerospace, defense, renewable energy, and more recently, sports science, because there's quite a bit of overlap that we can detect between not only motorsports and Formula One, but different types of sports science as well. So overlap in aerodynamic, all types of fields. Now, energy efficient performance. I think this is really what underpins everything that we do at Williams Advanced Engineering. And you can look at it as energy efficient performance, but we really look at it at each individual word. So energy, efficient, and performance. And anything that we do is going to be directly related to either all three of those words or at least one of those. Okay. A little bit more about the facilities that we have. We've got 2 wind tunnels on site, both a 50% scale one and 100% scale. We've got some battery build and tests, prototype build and tests, so some really nice fancy facilities which allow us to really collaborate with our partners and customers to custom develop or adapt an existing product. A little bit about our past. This is mostly our past in motorsports, which we first built up our expertise. More recently, we got involved with Formula E races. I'm not sure whether everybody is aware of the Formula E races, but this is the completely electric races that kicked off in, if I'm not mistaken, December of last year. We've successfully designed, developed, and manufactured the battery and the battery management system for all of the cars. And we recently had a race in Miami. Everybody's been very happy with the batteries that we've developed for this. All the cars are identical, so they all have the same batteries. And that has been a great piece of work for us. Porsche AG 911 GT3 are a hybrid, which was another one for us that has been incredibly successful. But I'm not going to go through every single one of those. This is a slide just with a couple of images that captures the sectors that we're playing in: automotive, motorsports, civil aerospace, renewable energy, and sports science. Okay, and I realize that we're at a medical or medical-related conference. We don't really play in this field as such, but there is some overlap there with, we do a lot of, obviously, data logging in F1. We log live data from the drivers. We do a lot of data analysis. You can see there's a lot of overlap there. We do a lot of simulation work, and we've got some solid expertise of that. And these are all things that I think relate very well to what I've seen here today as well. But I think my talk specifically is more focused on innovation in general, and we're not claiming that medical science or medical innovation is something that we've got extensive experience in. Just some of the partners that we've worked with in the past. Recently more in defense, Thales, BAE, so quite some big names in the new sectors. I'm just being conscious of time because I don't want to overrun. I'll focus on this slide in terms of capabilities. Lightweight materials technologies, obviously again from F1, carbon composites, metal alloys, intelligent combinations of functionality. Again, everything that we do is underpinned by efficient performance. high-performance hybrid systems, Formula One bred aerodynamics, high-performance driving dynamics, and specialist low-volume operations. So we procure and manufacture high-performance products in numbers from 1. It says here low thousands, but mostly a little bit slightly lower than that. And I think those are the core capabilities that underpin our organizations and that we try to match to needs in the market and see where we can contribute. Okay, these are the slides with all the images on that I said I'm just going to flick through. So lightweight structures, electric and hybrid propulsion, energy systems for both mobile and grid storage. So in terms of renewable energy, we recently embarked on a project that focuses on grid storage, hybrid grid storage, so supercapacitors and batteries for which we would provide the supervisory controls. So this is an area that I think is very interesting to us and again, obviously very much relates to energy efficiency. Battery charger, aerodynamics and thermal engineering, again, quite a bit of overlap if you look at sports science. That can be used as well, for example, bicycles and all types of other sports that this can be carried through. Aerodynamic systems. And this is quite specific. But when we look at control software, again, I think this is something that could overlap with the medical sector. We've got significant expertise there in both on the software and the hardware side of things. So I can see this being an area that we're going to exploit more extensively in the future. Okay, and I'll get to the data collection. Again, I mentioned just before, we do quite a bit of data collection on the F1 side. We have a whole team that focuses on this, and it's something that I think we can transfer into a variety of different things. It's not only how we collect data, but it's the speed at which we collect data and the manner in which we analyze data. Okay, because there's a lot of people that collect data, but it's really what you do with those data. Now, innovation. How do we approach innovation? What is the structure of our company as it stands? We are still 80% consultancy as it stands, and pretty much consultancy around automotive. But we're trying to branch away from that. We do some low volume manufacturing, but recently we started up a part of the business that's called Technology Ventures. And Technology Ventures is all about looking at new creative ideas and taking them to the market. Whether it's internal or external ideas, we're always open, we're always looking for interesting things that again match to the core of what we do. And if we believe this is something we can take forward, we're very interested, and I've seen a lot of very interesting things today, so please come and speak to us. We're always interested in case you have some further ideas. What we do, everything underpinned energy efficient performance. We look at where are the market's unmet needs, because there's a lot of very exciting technology out there, but there's really a need for something. So we explore where the need is, and we combine it with our capabilities and preferably move into high growth ventures.
Just a couple minutes.
Sure? Yeah, okay. So it can be driven, it can be supply driven or demand driven, which is pretty self-explanatory. So we can identify technology that needs an appropriate application, but we're still unsure where to find that. Or it can be demand driven and see where there's an existing gap in the market and the market needs a solution. This is quite a busy slide, but I think this really is the one that sums up what we do. So first is the first process in the innovation procedure is to gather knowledge. So we look at internally, F1 sponsors, partnerships, what are the trends outside. We look at innovation, IP holders, customers' needs, maybe potential funding opportunities that could lead to an interesting collaboration, IP opportunities. We look at what the market size is. Then we take that bag of information, we do an initial assessment, we do a sense check essentially, and if we feel, okay, this thing has got a little bit of legs, then we can, if it doesn't, we exit. If it does, we look into it a little bit further, and we look at the business case around it, so the business case viability. And that specifically focuses on customer, what is the market, what is the value proposition, do the financials stack up, what is the team going to look like, what is the technology development plan, how much investment is needed, and how much risk do we take on. So, I mean, depending on what kind of idea it is, we might be willing to take on some more risk. And then it moves into the concept phase, which is also where we'll start the creation of IP. We'll do some market testing and some further risk mitigation, and then we will start moving into development phase. We'll do some prototyping, testing again, market validation, and more risk mitigation. And then eventually we'll move it to market. And we try and find out what the correct business model is, who are the best partners to take this product to market, and what is eventually could be the exit strategy. So this is the core of what we do, and this is summed up in a very simple slide, whereas we start with an idea, filter it down to really what is the most interesting, move to a concept, do some product R&D, and eventually move into commercialization. So that's a bit about the innovation process. And again, we are relatively new as a company, so we're always still tweaking as we go along, but that's the bulk of it. A few case studies of what we've done as Williams Advanced Engineering. The CX-75 is a collaboration with Jaguar, and as mentioned in the video before, it has a performance of a Bugatti Veyron, emissions of a Prius, and a range of a Volt. And this has been our flagship project for the past couple of years. We've developed it really rapidly in 18 months. So I think if we say, okay, F1 expertise, what is really the core there that we do better than anybody else? It's speed. If we deliver a program like this in 18 months, I think it's pretty impressive, and we do it to the highest precision. So we're all very detail-oriented. There's a running joke in the company that we're all very obsessive-compulsive, which is not very becoming quality in real life, but actually in what we do, it's very good. Formula E races I already touched upon, Nismo GTR. Simulator capabilities, obviously where our main simulation capabilities come from is again from the F1 side, but we have developed this further for road-going vehicles. We've done custom-made projects for specific partners. We are currently involved, but I'll get to that later as well, in developing a simulator system for an autonomous vehicle environment. And again, this links into different markets as well. The Venture project, it's an Innovate UK project, which is what I just mentioned. It's a consortium with 10 UK partners. Atkins is involved, AXA is involved, and it's really looking at human reactions to autonomous vehicles. Our part is to develop a simulator. This is actually an actual simulator that we developed for Maersk Oil in Qatar. So we'll have a very similar simulator, but to see how it integrates with the autonomous vehicle, which I think for us is a very good learning curve to see what that space is about. It's going to explode in the next couple of years as well. So I think this is very interesting for us to be part of. Another one, Innovate UK project, is with a company that some of you might know, Aerodynamics, which is low-cost sodium battery technology, which is manufacturing using more sustainable materials. So in this case, it's sodium salts. What we're doing in this project is we integrate these into battery packs and battery management systems around it. Hardware and software part of this is it's part of what we do on this project. Another example of a technology that we've incubated very successfully is the Flywheel technology. I think this is one of our best known technologies, which obviously came from F1. Thank you.